Hi class, welcome back. Now we are going to have another lesson for today, or another new lesson for today. In our previous lesson, we were able to discuss the norms part 1. Again, norms is the average performance of a group or their specific variables or criteria rather. Now in this part, we are going more in depth about norms and the meaning of test scores part 2. Now let's go to the next page. Now let's talk about the normal distribution. So in our previous presentation, I was able to discuss about frequency distribution. Now let's talk about the normal distribution. Normal distribution is also known as the bell curve. It has the mean, median, and mode all at the center of the curve. So when you say normal distribution, it means it looks like a bell. It looks like a bell. Later I will show you an illustration of that. But when someone says normal distribution, that means it's a bell curve, and the mean, median, and mode is at the center of that curve. 50% of scores above the mean and another 50% of scores below the mean. That's why it looks like a bell curve. It shapes like a bell curve because, again, the mean, median, and mode are all at the center, while the 50% of scores above the mean and 50% of the scores below the mean are distributed in an average looking, shaping like a bell curve. I will show you later how it looks like. Alright, and then 68% of scores within one standard deviation from the mean. Alright, so for us to illustrate how this normal distribution looks like, I want you to recall the Cartesian plane. So in here, we have the Cartesian plane. We have the 4 quadrants. The upper right would be the first quadrant. The upper left is the second quadrant. The lower left is the third quadrant. And then the lower right would be the fourth quadrant. So in here, we have the x-axis. And then we have the y-axis. Alright, now let's focus on the quadrant 1 for this. Okay, now I want you to imagine that all the numbers on the x-axis would be the number of students, and all the numbers on the y-axis are all the number of scores. So, looking back to our frequency distribution, which shows us the frequent number of scores or points to a given test item or a student, for example, we already have that, then we are going to plot that in the first quadrant Cartesian plane. So for example, student A and B got 8 scores. So student A and B is two students. So 2 students got 8 points. So on x-axis, we are going to plot on number 2. And on y-axis, since the score is 8, we are going to plot on number 8 as well. So that would be the placement of the student on the Cartesian plane. Now let's say all of the students already have a scores and we already plot it. How does it look like? So a normal distribution would look like a bell curve. Let's go to the next page. So for example, we already plotted all of the students, and the Cartesian plane and its distribution looks like this. So in here, we can say that this is a normal distribution because this is how a normal curve, a bell curve would look like. So as you can see, this is the bell curve. We have here the percentage. So the percentage here entails to the population of the students. Okay, so for example, we have 100% for the whole population of the student. 34% of it got a low score, and another 30% of it got a high score. And then 14% of it got a lower score, a much lower score, and then 2% of it, 2% of the population got the least score. All right, so you can see here, the percentage here is the population. So for example, let's say that 34% of the student got 85 on the test, and another 34% of the student got 25 on the test. So it will show a normal curve just look like this. Okay, so the normal distribution entails to the normal curve or the bell curve that the test is neither easy nor hard. Okay, so it shows us that the test or the activity done is on its average performance, because not all students got high scores on it and not all students got low scores on it. So that what the percentage in here entails. Again, the percentage in here is the population, the percent of the population. Now below in here we have the 0, positive 1 SD, positive 2 SD, positive 3 SD, and then we have the negative 1 SD, negative 2 SD, negative 3 SD. Alright, so the 0 in here, 0 to positive 3 SD is on the first quadrant of the Cartesian plane, while the 0 to negative 3 SD in here is on the second quadrant. Okay, so I would just like you to picture on that. That's how it has a positive and a negative. I would just want you to imagine the Cartesian plane. Alright, going back. So the standard deviation in here is the units away from the mean. So let's say the peak of this normal distribution, it says here, is 0. So the standard deviation from the 34% of the student is positive 1 SD. So it means it is the standard deviation, the standard difference between the 34% of the students that got a high score, yes, would be positive SD. All right, or positive standard deviation. And then 14% of students away from the average performance of the class, 14% of it would be away from the mean to positive 2 SD, or positive standard deviation. All right, and then on the 2% of the class who got let's see. All right, now there are two concepts in the normal distribution. There are two concepts whenever we plot the scores of the student in a Cartesian plane. So first we have the skewness, and then the second would be the kurtosis. But let's go first to the skewness. Skewness is a measure of the asymmetry of the probability distribution of a random variable about its mean. So when we say skewness, it will show us the distribution of the students, for example, in a Cartesian plane. However, it is not symmetrical, just like the bell curve. It will not show you a very equal size. Like for example, in the previous slide, we have 30% of the students got highest, and then another 34% of the students got lowest. But in here, it might be 50% of the students got highest, and then 30% of the students got the lowest. So skewness shows us the not balanced bell curve. Later I will show you how it looks like. But for now, skewness shows us the asymmetry of the bell curve. Alright, skewness tells you the amount and direction of skew, departure from horizontal symmetry. So when someone asks you, alright, can you show me the skewness of the normal of the distribution? It entails to how much unbalanced is the curve. All right, it tells us how much unbalanced it is. Okay, so how much unbalanced it is on the horizontal symmetry, meaning on the Cartesian plane, that would be the x-axis. How balanced it is, how unbalanced rather. The skewness value can be positive or negative or even undefined. Alright, so skewness can be positive or negative, or something like cannot be defined, okay, because sometimes it looks like a group of mountains. Or sometimes it's a very, very big mountain or a volcano. It looks like that. So I will show you on our next slide how it looks like. Alright, so like what I've mentioned, skewness can be either positive or negative or undefined, but the most common types of skewness are negative skew and positive skew. Now let's look at the first picture. So that would be the negative skew. As you can see, instead of a bell curve that is on the center, okay, the peak is on the center. In here, the peak is leaning towards the right. That's the negative skew. Well, let's look at the second picture. The second picture shows you a bell curve that is leaning towards the left. So now let's define the negative skew and the positively skew. The negative skew, if the curve has a longer tail towards the left, it is said to be negatively skewed. So like what I've mentioned, the peak of the curve on the negative skew is leaning towards the right, and its tail towards the left. And then let's go to the positively skew. Positively skew, if the curve has a longer tail towards the left, it is said to be negatively skewed. All right. So okay. So in the positive skew, actually it's not the tail. Let's talk about the peak. Okay. So the peak is towards the left. Okay. That would be yes, on our left. Okay. All right. So when you're facing this computer, of course, that would be our left. Okay. So the peak of the curve of the positively skew distribution would be leaning towards the left, and its tail towards the right. All right. Okay. So, all right. So whenever you see a distribution like this, for example, we were able to create a distribution. Okay, we were able to create a distribution where the x-axis, which is the horizontal line, is the number of students, and then the y-axis, which is the vertical line, is the scores. Okay, so let's say that you're a psychometrician, okay, not a psychometrician, let's say that you're a teacher, okay, and you gave a test to your students, and then you plotted it on the x and on the y-axis, and it showed that it has a negative skew. All right, remember in mathematics, the center of the x and the y-axis is always 0. So for example, whenever you're on the x-axis, the the numbers away from the x-axis would be become larger. For example, at the center of the x and the y-axis would be 0. So the next one would be 1, 2, 3, and 4, 5, 6, 7, 8, 9, 10. So the farther the distance of the numbers from the center of the x and the y-axis, that would be the greater the number. Same that would be on the y-axis. Okay, I would just like you to get the picture. So for example, you got a negative skew, meaning that a lot of students got a high score. I mean, a lot of students, yes, got a high score, because again, x would be the number of students and then y would be the scores. Okay, so when you got the negative skew, it means that the test will be easy, or the test is actually easy, because a lot of students got high score. That is contrary to the positively skewed distribution. When you see this kind of distribution, it means that fewer students got fewer students got a high scores. It means that the test is harder. All right. Again, if you are giving a test to students, the negative skew entails that the score of the test, that is, it is easy, while a positive skew entails that the score is entails that the test is hard. Again, negative skew, the test is easy. Positive skew, the test is hard. All right. Okay, so here is the difference of the mean, median, and mode on both negatively skewed and positively skewed distribution. All right. So like what I've mentioned, a normal distribution entails to of a bell curve. So that would be on this the second picture in here. So it shows here that normal curve shows no skew or no asymmetry. So it means it is balanced. So you can see here at the peak, there is a mean, the median, and the mode. Again, the mean, it is the average. Median, which is in the middle, and mode, it is the most frequent scores. All right, so in here, at the center, at the second picture, it shows the normal distribution. All right, so now let's go to the negatively skewed. So again, the x-axis would be the participants, or for example, the students, and then the y-axis would be the distribution or the frequency. So in here, we have the negatively skewed. Okay, so it means it's leaning on the right. So it shows here that the mean is here. So it is on the left, followed by the median, and then the mode. So it means here that the average would be lower than the median, which is, again, median entails to the where there are scores, it is at the middle, where the one that is the middle, and then the mode is the most frequent. Okay, so this is what a negatively skewed distribution would look like. The mean, median, and mode looks like this. All right, again, it's leaning towards the right. Okay, that's actually contrary to what the positively skewed looks like. So as you can see here, just like the negatively skewed, the first one would be the mean. The mean is now on the excuse me, going or near to the right, while the mode is near to the left. All right. So as you can see here, that's why it's skewed, because it's not balanced. Unlike on the normal distribution in here, it is balanced. It's at the center. So if you are going to make a psychological test, make sure, yes, you're going to make a psychological test and you already practice administering it just to get the norms. Make sure that the mean, median, and mode will show a normal distribution or a bell curve. It means the test is either easy nor hard, and other variables are not being measured. All right, so that's the mean and median and mode for a normal curve will be at the center. That's why its standard deviation is 0. All right, so like what I've mentioned, there are two concepts that you should look at if you're talking about the normal distribution. The first one would be the skewness, which is asymmetry, and then the second one would be kurtosis. Now, kurtosis is a measure of detailedness of the probability distribution of a real valued random variable. Okay, so the term here is detailedness. I will show you how a kurtosis looks like. Now let's go to the next page. Alright, so when we say, when we are talking about the skewness, it entails to the imbalance or asymmetry. When we say kurtosis, it entails to the peakness of the distribution. Alright, so we have here three types of kurtosis. We have the mesokurtic, alright, mesokurtic, leptokurtic, and platykurtic curves. Alright, so the first picture would be, of course, the mesokurtic. The second would be the leptokurtic, and the third would be the platykurtic. Okay, so if you're going to look at the picture, it is very obvious that it is not a normal curve. It's not a bell curve looking images. Okay, so the first picture, which is the mesokurtic, is a bit flat. Okay, and the leptokurtic is a bit taller. Its peak is taller, and then the platykurtic it's actually flat. All right, so let's go and define it one by one. Let's go to the mesokurtic. Mesokurtic entails to the distributions that are moderate in breadth and curves with a medium peaked height. So its height is just medium. Okay, it means that its distribution are just average, as well as its breadth and its curve. So it's not as big as it can be. It's just a moderate. Okay, and then let's go to the leptokurtic. Leptokurtic, more values in the distribution tails and more values close to the mean, sharply picked with heavy tails. All right, so in here, so the key here it is it's more picked than the mesokurtic. All right, so that's the leptokurtic, and then the platykurtic, fewer values in the tails and fewer values close to the mean. For example, the curve has a flat pick and has more dispersed scores with lighter tails. All right, so it has a flat pick and the scores are scattered. That's why it's platykurtic. All right, so for example, you already have the scores again. So again, the x-axis would be the number of students, and then the y-axis would be this distribution or the frequency of scores. So a mesokurtic would be showing you that the students got, though almost a normal curve, however, the scores are very close to each other. Okay, so the high scorers is a bit closer to the low scores. The number of high scorers students are a bit closer to the low scores. All right, and that's different to the leptokurtic, because the leptokurtic shows you that a lot of students got high scores and students who got low scores entails to actually closer to the zero. All right, so it means that the test is either very easy. All right, it can be very easy. All right, and then on the platykurtic, it shows a very scattered score. So others got a minimum number of students got high scores, and another minimum number of students got a low scores. All right, it's scattered. That's why it's platykurtic. Okay, So when we say kurtosis, it shows as the thickness or the tailedness of the curve. It can be mesokurtic, leptokurtic, and platykurtic. Alright, so once you already have the bell curve, it's now time for you to define what norms are you looking for, alright? Or from the curve itself, you can say the normal average performance of either the score or the group or the people. Alright, so we have here, excuse me, the types of norms. Okay, so we have here again the type of norms. Okay, the most common type of norm, would be the developmental norms. Okay, so the developmental norms under it is the mental age, grade equivalence, and the ordinal scales. Now let's define first the developmental norms. Developmental norms indicate how far along the normal development path the individual has progressed. So developmental norms, it pertains to the average performance of a specific sample pertaining to its development. Okay, so to explain further on that, development norms include mental age, grade equivalence, and ordinal scales. So mental age, it pertains to the average performance of the mental age of the student. Okay, so remember that a mental age is different to chronological age, because chronological age, this is the age, the specific your specific birth age, okay, while mental age can be above your chronological age or lower than your chronological age. So developmental norms entails the mental age. So for example, excuse me, an 8-year-old who performs as well as the average 10-year-old on an intelligence test may be described as having a mental age of 10. Okay, so as you can see here, the 8-year-old has a mental age of a 10-year-old compared to a child who is also a 10-year-old. Alright, so that's the mental age. And then we also have the grade equivalence. The grade equivalence are scores on educational achievement tests, are often interpreted as grade equivalence. So, alright, so education, when we say grade equivalence, it entails to the grade itself. So when you're going, for example, you've given a test to a student and the score, an achievement test. Okay, so when we say achievement test is the knowledge that the child learned during the lesson or the lecture. So that would be the grade. Okay, so that would be the grade from that achievement test would be the norm for that. So that's the grade equivalence. And then the ordinal scales are designed to identify the stage reached in the development of specific behavior functions. Ordinal scales, these are actually scales. However, when you say ordinal, there would be order. So there's specific orders like 2, 4, 6, 8, 10. That would be the order. Or it can be increases or decreases like 10, 8, 6, 4, and 2. Alright, so when we say developmental norms, this entails the mental age, grade equivalence, and ordinal scales. Okay, so another way for us to get the norms would be the within group norms. When we say within group norms, the individual's performance is evaluated in terms of the performance of the most nearly comparable standardization group. Alright, so when we say within group norms, alright, so for example, you are already administered a test. Okay, you administered a test, and then the test, your target on the test would be grade 6 students. So you wanted to know the average performance of the student. So what you're going to do is that you're going to get another set of students that are also grade 6. and the performance of the students that you gave the test, its performance will be compared to the another group of students of the same criteria, or another group of grade 6 students. So with that, you are measuring the grade, the within groups, or when you say within, it is the same group. You're comparing your group sample with the same criteria of the group. Like for example, the grade 6, your samples would be the grade 6. You're going to compare it to another sets of grade 6 students. Alright, so like the example in here, comparing the child's raw score with that of children with the same chronological age. So again, in here, for example, the example in here shows to you that the child raw score, again, the raw score is different to the derived score, okay? So I've already discussed that in the previous videos, so please do check that out as well. Alright, so in here, you're going to compare the score of the child. For example, you have a you have a 9-year-old a child that you're studying. You wanted to know his or her performance by comparing it to another 9-year-old child. Okay, so that's, as you can see, that's within his or her group. That's why it's called within group norms. Alright, so another important aspects or definitions in here are percentiles, standard scores, and deviation IQ. So the percentiles entails to the certain numbers. It's okay. Percentile is shows you the outnumbered number of people from your score. Okay, so I will explain that further in our next videos. But in here, percentiles entails to your score compared to the outnumbered students. Okay, so for example, one of the famous tests here in the Philippines that uses percentile scores is the National Medal Admission Test. Okay, so you will not get a score that is 99. I mean, you will not get a score that is equivalent to your correct answer, but you will get a score based on the population. Okay, so for example, you got 99 percentile. It means that you're on the 1% of people who got high scores in the National Medical Admission Test. While when you got 20 percentile, it means you're at the lower 20% of the people who got low scores. Okay, so 99%. I mean, for example, let's go back to my first example. 99%. If you got 99 percentile, it means you're at the 1% of the people who got high scores. Okay, the 99 percentile, or the 99 percentile, you outnumbered them. Okay, and then the standard score, these are the scores, or the already derived scores. These are the standard scores. And then deviation IQ, so the difference, or the IQ compared to others. All right, so that's the end of this presentation. Rather, this is the end of the presentation. So it's a bit hard to explain online, but I've tried my best. But if you have any questions, please let me know in our chat, in our group chat rather. So thank you very much. See you on our next video. Bye for now.